Hi, this is Navin. My topic is Dynamic Memory Allocation. So, when a program is loaded into system memory, the place where it is stored is divided into three categories: stacks, heaps, and code. The stacks are used for storing static variables which are declared prior to compilation. These variables and arrays, also including main, are stack space. The heap is exclusive for dynamic memory allocations. They are allocated randomly. They gradually grow from low address to high address, whereas stacks grow from high address to low address. The code can be furtherly classified into BSS segment, data segment, and text segment. The BSS segment stores uninitialized static variables, whereas the data segment stores static variables which have been initialized. The text segment stores the executable statements of the program. Dynamic memory allocations means allocating the storage spaces for variable at the runtime or the compilation time of the programs. The memory is managed when the program is being compiled. So they are done by four functions, namely malloc, kalloc, realloc, and free. So these four functions are declared in standard library.h, which means stdlib.h. So dynamic memory allocation generally uses heap space for system memory. Memory allocated by C dynamic allocation function is obtained from heap. The heap is a free memory that is not used by a program or operating system or any other program running in the computer. The size of the heap cannot be usually known in advance, but typically contains a fairly large amount of free memory. The size of heap is large, it can be finite and exhausted. The malloc function allocates the memory and free function releases it. That is, each time a malloc memory request is made, the portion of the remaining free memory is allocated. Each time a free memory release call is made, the memory is returned to the system. Any program that uses these functions must include the standard header file stdlib.h. The syntax of malloc is pointer equals cache type malloc byte size. So the cache type is the data type. In this example, it's given int pointer variable is declared and cache type is given malloc 5 and size of int. Size of int can be 2 or 4 bytes depending on the compiler. So this statement allocates a 20 bytes of memory, that is 5 into 4. So the malloc returns a pointer to the first byte of the region of memory of the same size, let's say 5 in the prior example, that has been allocated from the heap. If there is sufficient memory in the heap to satisfy the request, malloc returns a null pointer. We should check the return is not a null, because if it's a null, it would probably cause a system crash. So the next is kalloc. Kalloc or contiguous allocation method in C is used to dynamically allocate a specified number of blocks of the specified type. It initializes each block with default value 0. The syntax is ptr cache type kalloc n element size. So the kalloc allocates the memory and also initializes the allocated memory block to 0. Unlike malloc, kalloc takes 2 arguments: the number of block to be allocated and size of each block. So in this example, I have declared int pointer equals int kalloc 5 and size of int. So there are 20 bytes of memory is allocated. They are one after another. 5 blocks of 4 bytes each dynamically allocated to ptr. Kalloc function returns a pointer to the first byte of the allocated region. The memory is insufficient to satisfy that request. A null pointer is returned, which is the failure of allocation. Next is realloc. Realloc means reallocations. The precise operation for realloc differs between two different versions of C, which is C89 and C99. Although the net effect of the operation is same, realloc should be only used for dynamic memory. If the memory is not dynamically allocated, the behavior will be for C89 version of C, realloc changes the size of previously allocated memory pointed to the variable that to the specific size. The value of this size may be greater or lesser than the original, whereas in C89 the block of memory pointed to bit is freed and then a new block is allocated. If a pointer to memory block is returned, the old blocks are copied into the new box in C89 version. C99 version, if the old block and new block should begin at the same address, the pointer passed in realloc function should be the same as used in variable PTR. And if it's 0, it simply allocates the size which is specified bytes of memory and returns the pointer. And if the size is 0, the memory pointed to by the PTR is freed. If there is not enough free space in the heap section of the memory to allocate the required number of bytes, a null pointer is returned and the original is left unchanged. Void realloc function inside the parenthesis, void pointer and size. Here the size t is nothing but a variable. Look at the example. Storage is dynamically allocated. Say if you want to add new blocks to the existing array, you cannot simply add or append because arrays are stored in a consecutive memory and you never know whether or not the memory immediately after the array is already allocated for something else. Here 20 blocks of memory is extended to 40 blocks. This is executed as computer change pointer from 20 blocks to 40 blocks, that is 10 into 4 dynamically. The next is free function. If an null pointer is passed to a free function, no operation takes place. The syntax is void free and cast type pointer or variable. The free method in C used to dynamically deallocate the memory. The memory allocated for function using malloc or kalloc is not deallocated on their own. Hence, free function is used to deallocate them. It helps to reduce wastage of memory by freeing it. Free function can only be called by the same pointer that was previously allocated using one of dynamic allocation system functions. Passing an invalid pointer will most likely to create bugs and destroy the mechanism. So these bugs will be harder to find because their location is unknown. Now look at the example. So 20 bytes of memory is allocated for PTR and the statement free PTR releases the memory and it can be used for further more new allocations. So here are some pros and cons of dynamic memory allocations. The advantages are we can allocate additional storage whenever we need them. We can deallocate using free or delete functions dynamic space whenever we are done with them. So data structures can grow and shrink according to their requirement. That's the advantage. And the disadvantage is as the memory is allocated during the runtime, it needs more time for the program to complete. The memory needs to be freed whenever the compilation or the program is executed.